Okay, I'm going to run through all the problems on the Mod 10 review, and that should help you out. So first, number one here, explain what you would do to show each of the following on the coordinate plane. So if we wanted to show that two segments are congruent, what we would need to do is we would use the distance formula to find the lengths. So use the distance formula to find the lengths. I'll say use the distance formula to show same length. Okay. If we want to show parallel lines, what we would do is we would use the slope formula, and we would use the slope formula to show same slope. Remember, if they have the same slope, they're parallel. Perpendicular lines, what we would do is we would use the slope formula to show opposite reciprocal slopes. And remember what opposite reciprocal slopes are. If one of the slopes is 2/3, so I'll say example, one of the slopes is 2/3, the other slope would be -3/2. So flipped fraction and change sign. That would show that there would be a 90-degree angle. That would show that they're perpendicular. Okay? Alright, so we got that. Write a strategy to show that a quadrilateral on the coordinate plane is a parallelogram. So the way that we've been focusing on it is really just to show that we've got parallel, so the opposite sides are parallel. So the strategy is that we want to show opposite sides are parallel. So, and then we would of course use the slope formula. And that would show that it's a parallelogram. So we would have, we would show these sides that are opposite, they have the same slope, and then these other ones would have the same slope, so bam, parallelogram. Alright, next, let's see what we got here. So let's say we already know that it's a parallelogram and we're trying to figure out if it's a rectangle. What's the quickest way? Now there's some debate on this. If you already know it's a parallelogram, then you already have parallel and you have parallel, right? So parallel. Now what you want to do is you want to show that it's a rectangle. Now remember, a rectangle has one right angle right there, and once it has one right angle, it actually means that all four of them are right angles. So what you could do is you can just calculate the slopes, and you want to see if the slopes are opposite reciprocals. So the slope of this segment and the slope of this segment. So we could say calculate slopes and see if adjacent sides have opposite reciprocal slopes. Okay, remember, if these segments here, if their slopes are opposite reciprocals, then that means they're perpendicular. And if they're perpendicular, then that means there's a right angle there, and then it's going to be a rectangle. So that's one good way. Is that the fastest? I don't know. So that's calculating these two slopes. The other way, so that's one way, the other way is you can use the distance formula and you can show that the diagonals are congruent. So if the diagonals are congruent, then that's a rectangle as well. So I'm going to make a note. I can say use distance formula to show diagonals are congruent, that they have the same length. Okay, that would make it a rectangle if it's already a parallelogram. Alright, next, a rhombus. Okay, so you already know it's a parallelogram, so you've already got, again, you've got parallel, 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 parallel. And you're wondering, is it a rhombus, meaning that all of the sides are congruent? Well, the quickest way probably is to use the fact that a rhombus has diagonals that are perpendicular. So that's what you want to do. You want to calculate you want to show the diagonals have perpendicular, show the diagonals are perpendicular. So show diagonals are perpendicular. This is perpendicular sign. Okay. How would you show that? You would calculate the slopes. So calculate the slopes, and remember slopes would be opposite reciprocals. So slopes of diagonals are opposite reciprocals. Think that would be the easiest, quickest? Sorry about my spelling there. Okay. So, and then the other thing you could do, but I don't recommend it, is you could do the distance formula 4 times, and that would show that all those lengths are the same. But I think it's easier just to use slope and show these are perpendicular. Okay? Alright, next, let's see what we got here. Okay, it's a parallelogram already, and we're trying to show that it's a square. Already a parallelogram. So we already have parallel, 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 parallel. Alright, so we have 2 things we need to get here. We need to make sure it has a right angle there, and then we also want to make sure that all the sides are the same, all the sides are the same length. So couple ways to do it is you could same thing we did for the rectangle, so we can try to calculate the slopes here and see if we have opposite reciprocals. If we do, then it's already a rectangle, and then we just want to figure out if it's a square by also calculating the slopes of the diagonals and seeing if these are perpendicular. So if we have the 2 sides are perpendicular and then we have the diagonals are perpendicular, then it's a square. So that's just a lot of slope calculations. So that's probably the best way to do it, quickest way to do it. So to put that down on paper here is we would say we need adjacent sides have opposite reciprocal slopes, and these are the sides that are right next to each other. And what that would prove is that then it would be a rectangle, and then I'm going to say and we would then need to do the diagonals. So diagonals, I'm going to say diagonals also have opposite reciprocal slopes. And that would show that it's a square. Okay? Because this, the adjacent sides having opposite reciprocal slopes, this would show that it's a rectangle. So this part, the part in red, would show that it's a rectangle. And then the blue would show that it's a rhombus, and when you combine a rectangle and a rhombus, that's what makes a square. So the square has, all the properties. Alright, next, start getting into some actual problems here. So we want to show that this quadrilateral is a rectangle. So what we could do is we could just do a lot of calculations of slopes. So let's calculate slope, slope, and then see if they're opposite reciprocals, and that pretty much would do it. So strategy, we're going to show, let's show that AD is parallel to BC. These are the sides that are opposite. And then we're going to show the other opposite sides. So we're going to show, because we're going to make it a parallelogram first. So we're going to say AB is parallel to DC, and then we're going to compare these slopes and see if we have opposite reciprocals. So we're going to show that AD is perpendicular to AB, and the work is going to be just slopes. Alright, so let's do the work. So we're going to subtract, let's figure out the slope. These are all slopes, okay? So slope of AD, so we're going to subtract those y's on top. So it looks like we're going to have 9 minus 4, and then on the bottom we're going to have negative 3 minus a negative 8. So on the top it looks like it's 5, and then on the bottom that's negative 3 plus 8, so that's actually 5. So this is slope of 1. And then we're going to do, let's do the one that's opposite that. So that would be BC. So let's do BC, slope of BC. So that looks like it's going to be 3 minus a negative 2. And then on the bottom, that's going to be 3 minus a negative 2 as well. So that looks like it's going to be 5 over 5, which is 1. So these are parallel, so that's good. And then let's calculate the other ones. So let's do AB. So slope of AB, that's a little messy, sorry. Slope of AB, we're going to do 9 minus 3. And then on the bottom, we're going to do negative 3 minus 3. So that's going to be 6 over negative 6, which is negative 1. And then let's check out the opposite side there, that slope. So that would be CD or DC, whatever you like. So let's do DC. So that would be 4 minus a negative 2. And then on the bottom that would be negative 8 minus a negative 2. So that's 6 over, that's negative 8 plus 2, so that's negative 6. That's negative 1. So we have parallel. So we have the ones across from each other parallel, so it's definitely a parallelogram. Then what we want to do is compare the slope of AD with this slope, with the slope of AB, and we can see that they're actually opposite reciprocals, and so we have a right angle. So that means that we did show that AD is perpendicular to AB because they have opposite reciprocals. We have parallel, parallel, so it's definitely a rectangle. Okay, So that's really the explanation. You know, a lot is in the work there. We can put it down in words as well. Actually, I have it on the next page in words a little bit more, so I'll have you look at that. So, explanation right here. It says AD is parallel to BC because they both have slopes, so that's these ones. And then AB is parallel to DC because they both have the same slope of -1. And then, so that makes it a parallelogram because they have opposite sides parallel. And then we showed that AD is perpendicular because they have opposite reciprocal slopes, 1 and -1. This shows that ABCD is a rectangle because it's a parallelogram with one right angle. So, pretty wordy, but do your best on that. Alright, so now we want to show that parallelogram MNOP is a square. So I probably need to plot these points real fast. Okay, so just so we have some picture. So -1, -1. Oh, that's not -1, -1. Okay, -1, -1. So right there. 4, 4. 9, -1. 4, -6. Let's see, that'll be right there. Okay, so then I'll connect these. Okay, and you probably should label them. So let's see, I got M, N, O, P. Alright, so we want to show it's a square. So how are we going to show it's a square? Let's see, what's the best way? So it's already a parallelogram, so they're telling us it's a parallelogram, so we already have parallel, parallel. So we already have parallel, 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 parallel. Okay, so now we want to show it's a square. So we probably could calculate some slopes and try to see if we've got, there's a couple ways to do it. That's the way I would do it. I would calculate slopes and see if you get opposite reciprocals, and then I would calculate the slopes of the diagonals to show that you have opposite reciprocals. That's the way that I like to do it. So that's what I'm going to say. I'm going to say show opposite sides have opposite reciprocal slopes. No, not opposite sides, sorry. Adjacent sides. Right, the ones right next to each other. So show adjacent sides have opposite reciprocal slopes. That would show that they're perpendicular. And then the other thing we would want to do is we want to show diagonals have opposite reciprocal slopes. And that would show that the diagonals are perpendicular as well. So that would make it a square. So let's do a little bit of work. Let's see. So let's calculate this slope and this slope. So let's do MN. So let's see, slope of MN. Alright, so MN, so we're going to subtract the y's on top. So that would be 4 minus a -1. And then on the bottom it would also be 4 minus a -1. So that would be 5 over 5, which is a slope of 1. And then let's do NO as well. So NO, and let's see if that slope is an opposite reciprocal. So NO, we're going to subtract the y's, so that would be 4 minus a negative 1. And then again, it doesn't matter which one you do first, you just have to be consistent. So 4 minus a negative 1, and then I'm going to do 4 minus 9. So that's going to be 5 over negative 5, which is negative 1. And look at those are opposite reciprocal slopes. So that's what gives us a 90-degree angle right there. The next thing I would do is I would calculate the slopes of the diagonals. So let's look at the slopes of the diagonals. So that would be, so I'm going to say slopes of diagonals. Okay, diagonals, so one of the diagonals is MO, so let's do that. So that would be, let's see where MO is. Okay, so I'm looking at my coordinates to do this. So I'm going to do negative 1 minus a negative 1. And then on the bottom, I'm going to do negative 1 minus 9. So on the top, it looks like it's going to be 0 over negative 10, which would be 0. So no surprise, because MO looks like it's a horizontal line, so it has a slope of 0. Okay, then we're going to do NP, which is straight up and down there. And whenever that's straight up and down, you already know it's going to be an undefined slope. But if you do show a little bit of work, so let's do NP, slope of NP. Ooh, that's going to be tiny. So NP, so that would be negative 6 minus 4. And then, let's see, negative 6 minus 4, and then 4 minus 4 on the bottom. So you can see it's going to be negative 10 over 0, and that's undefined. So 0 and undefined are always creating a perpendicular, because one of them is a horizontal line and the undefined is the vertical line. So that creates a perpendicular right here, and that's what makes it a rhombus. And so a rhombus and a rectangle put together creates the square. Okay? So that proves that it's a square. So we have a combination of rectangle, because of the right angle is opposite reciprocal, and then we have the diagonals, so then we have the rhombus, combination of those two, and that's what makes a square. Okay, so if you say something like that, that would do it for me. Okay. Alright, so let's see what we got next here. So I'll go ahead and include that work. That's another option. So this one is showing the work that they calculated the distance. So they did a couple segments. So they did the diagonals congruent, which is another way to make it a rectangle. And then they did the slopes of the diagonals to show the slopes are opposite reciprocals, or the slopes are perpendicular, so that makes it a rhombus. So two things make it a rectangle: the fact that the diagonals are congruent, or if you just want to do what we did and we compared the slopes of these and we got those to be opposite reciprocals. So you think about that, because you do have some options. Okay, so moving on to the last learning target. So we're going to talk about area and perimeter. So the two formulas that you really want to have memorized: area of a triangle. So area of a triangle is just 1/2 base times height. And then area of a rectangle is just, it's really just length times width, but you can just say base times height. Okay, same thing. So base times height. So you have a rectangle like this. This would be like your base, and this would be your height. And then if you have a triangle, this is your base. This would be your base, and then this would be your height. And it's 1/2 that. All right. Okay, this says find the area and perimeter of the rectangle. So let's see. First, let's find the perimeter. So we need to find some distances. So now we actually do need the distance formula. So here's the distance formula. It's a big ol' square root, and it's x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Alright, so let's find some lengths here. So let's find ST. Alright, big ol' square root. Okay, so we're going to subtract the x's. So I'm going to do -1 minus a -2 squared plus, and then I'm going to subtract the y's. So I'm going to do 4 minus 1 squared. Okay, so that's going to be -1. It's actually going to be plus 2. So -1 plus 2 is 1. So this is 1 squared plus 4 minus 1 is 3. So that's going to be 3 squared. So showing a little bit more work. So this is going to be 1 plus 9. So this is square root of 10. So ST is square root of 10. This is a rectangle, so that means this is square root of 10 as well, straight across. And then let's find the other length. So let's find the Q. Well, let's see. Let's find SR. Let's do this bottom one. So SR equals big ol' square root. So we're gonna subtract the x's. So let's do -2 minus 4 squared plus 1 minus a -1 squared. So that's going to be -2 minus 4. So that's going to be -6 squared plus 1 minus a -1 is actually 2 squared. So we've got 36 plus 4, so square root of 40. Sound good? Square root of 40. So that means this is square root of 40. I'm not going to worry about simplifying radicals right now. So square root of 40 across from each other. So let's do the perimeter. So perimeter is just adding up all of the outside. So perimeter equals adding all those up. So it's going to be square root of 10 plus square root of 10 plus square root of 40 plus square root of 40. And you can just do that on your calculator. So that would be, I think it's about 19 units. So I'm going to do it real quickly. So square root of 40 plus square root of 40 plus square root of 10 plus square root, booger, messed up. Oh, booger. Sorry, carabamba. Okay. Square root of 10. Okay. This is about 18.97. So it's about 19. Okay. So it's about 19.0 units. Okay. Alright, so that's perimeter. Now area of a rectangle is just the base times the height. So area is base times height. So the base, let's say that's square root of 40. And then we're going to multiply that by the height, which is square root of 10. And then we just put that into the calculator. So that's square root of 400, by the way, right? So let's just do that on the calculator. So that's square root of 40 times square root of 10. That's 20. Yeah, because it's a square root of 400, and that's a perfect square. So square root of 20, and it's technically units squared. If it was centimeters or something, then it would be square centimeters. But we don't really have any, units, so they're just square units. Alright, so we got that. I'll go ahead and just include that page. Okay, so now we're going to find the area and perimeter of this triangle. So let's first plot it. So I got negative 4, 5, 1, 2, 3, 1. Okay, so there's A. And then B, negative 4, negative 6. 3, 4, 1, 2, 3, 4, 5, 6. Okay, so that's B. And then C is 4, 1. 1, 2, 3, 4, 1. C. Okay, so then we'll connect these. Little technical difficulties, sorry. Alright. Okay. So we want to find the area and the perimeter. Okay, so first we're going to probably need to find some lengths here. So let's find the length of AB. That one I would just count. So you can just count. So I'm going to put the unit, the coordinates just right next to it. So A, that's negative 4, 5, and then C, 4, 1, okay. Okay, so you can count from here to here. That's 11 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so you can count, that's 11 units. If you can calculate it, you do 5 minus a negative 6, that's 11. Okay, now the other ones we're going to need to do the distance formula. So we're going to have to do AC, we're going to have to do the square root and do the distance formula. So that's negative 4 minus 4, we're going to square that, and then we're going to subtract the y's. So let's do 5 minus 1 squared, so that is negative 8 squared plus 5 minus 1 is 4 squared, so that's going to be 64 plus 16, so that is how much? Square root of 80, I believe. Yeah, should be square root of 80. Okay, then let's do, so this one is square root of 80, and this one we said was 11. I should do that in a different color. So 11, square root of 80, and then we need to do BC. So let's do BC, so that's square root, so we need to subtract those x's. So let's do negative 4 minus 4 squared plus, and then we're going to subtract the y's, so negative 6 minus 1 squared, so this is going to be negative 8 squared plus negative 7 squared, so this is square root of 64 plus, and that would be 49. And then this would be square root of, let's see, be 113, right? So 113. Let me just check that one real quick. Okay, so that means this length is square root of 113. Okay, so let's do perimeter. So perimeter would be adding all these together. So perimeter equals 11 plus square root of 113 plus square root of 80. And if you wanted an exact answer, that's really the exact answer. Or you can say it's approximately, and then you just do that on your calculator. So I would say, let's see if I can do that on my calculator. So that would be 11 plus square root of 113 plus square root of 80 equals, I got about 30 point, let's say round it to 6, so 30.6, okay, it's perimeter. Area is 1/2 base times height. So the base, this is like this triangle on its side, okay, so this is the height, and this would be the base. This is the base, turned sideways, okay. So area equals 1/2. The base then would be 11, and then the height is, let's see, we got to figure out the height. So how many units is that? 1, 2, 3, 4, 5, 6, 7, 8. So I'm counting this. This is 8 units from there to there. So that's 8. And then we just multiply those two, multiply all that together. So this gives you, it's 88 divided by 2, so 44. And that's 44 square units. Right? Okay, we're getting there. Okay, I'll include that. Uh-oh, I'm hearing some noise coming in my house. Hopefully they're not too loud when they come in. Alright, kite. Now what I would do with a kite, oh, I got a bumba. Kite, quiet dogs. I'm making a video. Okay, so with the kite, I would break it up into 2 triangles. So let's say area of a kite is area of triangle plus triangle. And the area of a triangle we know is 1/2 base times height, and we're going to do that same thing twice. Okay, so we're going to have 1/2. Let's figure out the base. So the base is this length right here. So let's figure out how many units that is. So let's just count. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like 9 units. So that's 9. So this is 9. So that'll go here. And then the height is this length from here to here. So we can count that too. So that's 1, 2, 3, 4. So we'll put in the height as 4. Okay, so we got same thing twice. So base 9, and then again the height is this length here, so that's 4. So let's do the math. So that would be, this is 36 divided by 2, so 18, and then 18 again. So that's 36. So that's 36 units squared. Alright, I'll include that. And then the last one is this shape. And if you want to find the area of this shape, I would break it up into different parts. So break it up into triangles. So there are 2 triangles there, and then a rectangle. So let's label them. So this is triangle 1, this is triangle 2, and then this would be rectangle. I'm going to call it figure 3. Okay, so let's do area of 1, and that's a triangle, so it's 1/2 base times height. So the base of this one looks like we can just count 1, 2, 3, 4. The height is right here, it's 2 units. So the area of that first triangle is 4. Then we're going to do the area of the second triangle. So it looks like it's a right triangle. So you have a base and a height. So it doesn't matter which one is which, because you're going to be multiplying them together. So let's say that this longer one is the base. So let's do 1/2 base. So it's 1, 2, 3, 4, 5, 6 units. And then the height would be 1, 2, 3, 4 units. So the area of the second triangle is 12. Then let's do the rectangle. So that's this one. So area of 3, and that's just base times height. So base, let's say, is the long one. So 1, 2, 3, 4, 5, 6. And then the height, 1, 2, 3, 4. So that's 24. So the area of this whole, whatever this shape is, so the area of this STUVWX is equal to 4 plus 12 plus 24. So it's 40 square units. And that should do it. So I'm going to say good luck on your last mod quiz.